Alright, so the beginning of this section, hopefully you've watched the video. It's a little bit out of sequence, but it's titled 3.4 Intro. What is the difference between permutations and combinations? That was the Usain Bolt example that we did with the track and field racing. So we've talked all the examples we've done so far have been about combinations. I now want to show you how it works with permutations. Okay, so here's an example. And the idea behind combinations is there any difference between like a ham and cheese sandwich or a cheese and ham sandwich? And the answer is not really. I mean, some people might dispute that, but the idea is there are certain cases where order doesn't matter. Order is not important, right? I gave you the track and field example. If it's a qualifying heat and Albert, Bernard, and Charles finish in that order, or it goes Charles, Bernard, and Albert, we don't care about the order right here because all three of them get to go to the final in either case. The order doesn't matter. Okay, you're probably familiar at this point on the calculator with going to NPR, where P means permutation. And again, the way that I remember this is permutation starts with the letter P, which means position matters. Position also starts with P. Combination is on the calculator, it's not going to be NPR, it will be NCR. Okay, and this is the total number of things that we're choosing, and I think of C as meaning not only combination but choose, whereas P usually we say pick. So for example, you could have 8 people and pick 3 of them, or you could have 8 people and choose 3 of them. And choosing combinations are going to be far less amount of things because we don't want to double count all of these, or it would be more than double counting. We wouldn't be counting all of these different things as really being different. These are all the same. Right? The other possibilities would be ACB or BAC. So it looks like all 6 of these are really just one result when we're talking about combinations. Okay, which means there will be far fewer numbers. All right, so the actual formula for this, you might, you don't have to know this to figure out the problem, but you might recognize this as very similar to the permutations formula. So the permutations formula looks like this. Okay, the permutations formula, so for example, if I were doing 10 items and I were picking 3 of them, it would be 10 factorial over 10 minus 3 would be 7 factorial. On the other hand, if we're doing combinations, it's going to be n factorial over, it's almost the same formula, it starts out the same. We have to divide this extra r factorial right here because that's getting rid of all the repeats. So on that other example we just did with track and field, there were 3 people finishing. So we would have divided by 3 factorial. We divided by 6. And you can probably tell from looking at this there are 1, 2, 3, 4, 5. There are 6 duplicates basically every time somebody finishes that race. So let's actually do an example. I think that will be clear. It says a State Department of Transportation plans to develop a new section of interstate highway, gets 16 bids for the project. The state is going to hire 4 of the companies. How many different combos of 4 companies can be picked from 16 companies? So we could say company 1, company 2, company 3, etc. And there's 16 of these. So why would this be a combination instead of a permutation? Remember, combination order doesn't matter. Does it matter if I hire company 5 followed by company 2 followed by company 8 followed by company 11? Is that going to be any difference versus if I did company 11, company 5, company 2, company 8? Does it matter? And the answer is no. Remember, if you're hiring 4 of the companies, these 4 companies will get hired. If I'm in company 5, hey, I'm happy because I got hired. Am I any less happy if I got hired second versus first? No, I'm not, because I got hired. As long as I'm in the group of 4, it really doesn't matter what order I got hired. That's different than finishing a gold medal race, where it does matter a lot if you finish in first versus second versus third, let's say. Or if it's an Olympic race and you finish 4th, that's a lot different. You didn't get a medal at all versus finishing first. Here, company 5 is getting hired. Here, they're getting hired. It's not like I'm getting the gold here and the silver here. I'm getting hired. That's all I care about. So it's going to be, remember, NCR. N is the total number of things. How many total bids do we have? We have 16. We are choosing, not picking, because the order doesn't matter here. We're choosing how many? We're choosing that amount of things, which in this case is 4. So on the calculator, you would do 16, and then you would go to NCR, which is under Math PRB, just to recall that. And then I think it's going to be, let me just double check on mine right now. NCR is, on mine it's 3. It says NCR. And then you go back to the main screen and type in 4. And this turns out to be 1,820 ways that we could pick 4 companies out of those 16 companies.